Okay, so in this class we're going to talk about the slope-intercept form of the equation of a line. And there are generally three ways we write the equation of a line. There's the slope-intercept form, point-slope form, or standard form. So this is slope-intercept form, and it looks like this. It looks like y equals mx plus c. Okay? Y equals mx plus c. So y is some multiple of x plus a constant. Notice this is not a direct proportion because it's not just y equals a multiple of x. This is not a direct proportion, which means it's not going to pass through the origin, unless of course c is equal to 0, in which case it would be a proportion. So what we're talking about, if we're saying y equals mx plus c, that means every point x comma y can just be written as x comma whatever mx plus c is, because y is equal to mx plus c. So that quantity there will be the same as that quantity there. Okay, so if I look at this equation here, y equals 2x plus 1, it's y equals some multiple of x plus, a non-zero number in there. I know it's not a direct proportion, because if it was direct proportion, this would be just plus 0. There'd be no constant in there other than 0. So it's not going to pass through the origin, but we're going to investigate, see what it looks like. So again, we're going to investigate on this domain, just because it's nice and simple. -2, -1, 0, 1, and 2. And I emphasize that there are actually infinitely many values between -2 and 2. We've just selected 5 to see if we can spot the pattern. Now the y coordinate is always going to be double the x coordinate and then add 1. So double -2 is -4, add 1, -3. Double -1, that's -2, add 1, -1. Double 0, 0, add 1, 1. Double 1, 2, add 1, 3. Double 2, 4, add 1, 5. Okay? And let's investigate the changes. Well, the change in x, again, I've just chosen this to be increasing by 1 unit each time. The change in y, you can see -3 to -1, that's an increase of 2. -1 to 1, increase of 2. 1 to 3, 3 to 5, increase of 2. So delta y divided by delta x is constant all the way down. It's always 2. Remember, that's the slope. So this is going to be a linear equation. We know it's linear, of course, because it's 2x to the power of 1. Linear polynomials are degree 1 polynomials. And that's 2. And again, let me just throw in some kind of just increase that by, say, 100. So if I increase my x by 100, my next value for x will be 102. My next value for y will be double that, 204 plus 1, which would be 205. Which would be an increase of 200 from the previous y value. And again, the change in y divided by change in x, 200 divided by 100 is 2. It doesn't matter what. Once I'm following this rule, we're always going to get 2 down here. Which means the slope is constant, which means it's a straight line. And a couple of things to note. A really important point within here is this point here, 0, 1. Well, if the x-coordinate is 0, that means it's on the y-axis. Where? It's on the y-axis 1 unit up. That's called the y-intercept. So notice here what we're saying, even before I graph it, we'll confirm this with the graph in a moment, but we're saying the slope over here is 2. That number there. And the y-intercept here is 1. That number there. Slope 2, y-intercept of 1. And if I go and graph it, and again I've already done one out on GeoGebra, there's the graph. -2, -3, -1, -1, 0, 1, 1, 3, 2, 5. Again, let's just look at the slope in there. Run of 1, rise of 2. Change in x is 1, the change in y is 2. And that's, the change in y is always going to be double the change in x over any interval. If I took the whole thing, the change in x over the whole interval here, and the change in y, well, the change in x over the whole interval would be 4, and the change in y going from -3 up to 5, that would be 8. Delta y over delta x is always 2. So what we're seeing here is that this is the slope, this is the y-intercept. So that's why it's called the slope-intercept form. Once we see it in this form, we can say that's the slope, and this value out here is the y-intercept. Okay, let's have a look at another one. So y equals negative x plus 2. Y equals negative x plus 2 on the domain negative 2 to 2. Now, the coefficient of x here is negative 1, so I'm going to hazard a guess here that the slope is going to be negative 1, and the the constant being added on here is 2, so I'm going to say the y-intercept is 2. Slope negative 1, y-intercept of 2. Let's go through them. X, again, I'm just going to select 5 nice easy values from this interval which contains infinitely many numbers. Y is always the negative of x with 2 added on. So the negative of negative 2 would be positive 2, and then add 2, that would be 4. The negative of x here, the negative of negative 1 is positive 1, add 2, that's 3. Negative 0 is just 0, add 2, that's 2. You can see the pattern here. Negative of 1, negative 1, add 2, 1, negative 2, add 2, 0, 4, 3, 2, 1, 0. Looking at the changes in x, well, I've chosen these things to be increasing by 1, and that's forced these things 4 to 3. Well, that's a decrease of 1, decrease of 1, decrease of 1, decrease of 1. So if I look at each delta y value and divide it by each delta x value, negative 1 divided by positive 1, negative 1, and that's the same all the way down. And again, if I looked at increasing by, some number here, let's just put in adding 10 on here to my x, the change in x to 10 would mean my next x value would be 12. Y is always the negative of that, negative 12 plus 2, that would be negative 10, which would be a decrease of 10. Again, delta y divided by delta x, negative 10 divided by positive 10. That's negative 1. So the slope is constant here. Remember, this is what the slope is. It's the change in y divided by the change in x. It is negative 1. It's the coefficient of x in there. And the y-intercept, where in my table can I see my y-intercept? There, because when x is 0, we're on the y-axis, a y-intercept of 2. And again, there's my equation of the line. Sorry, there's my graph of the line, I should say. Negative 2, comma 4, negative 1, comma 3, 0, comma 2, 1, comma 1, 2, comma 0. The slope, a run of 1, a run of 1 is a rise of negative 1. It's falling here, so the rise is negative. Also, note the y-intercept, there it is at 2. So the big thing to remember, y equals mx plus c. M is the slope, and c is going to always give you the y-intercept. And you need to know that. You need to be able to look at an equation and say what its slope is, say what its y-intercept is. Really straightforward. Okay. So let's look at doing a little bit of investigation on GeoGebra here. So I'm just going to dig up a GeoGebra file, and I'm just going to type in a couple of things. I'm going to put in a couple of sliders here. So let me put in a slider and let me call it M. And let me put in another slider and let me call it C. Okay, actually let's put in the increments of 1 just for the moment. Settings, increments of 1 just for the moment, just to see what's going on. It's easier to spot if I do that. And then I'm going to define a line to be y equals mx plus c. Again, I really encourage you to practice this. And I'm going to also use my slope function here. I'm going to hit slope and just click on the line, and it puts up the slope there. At the moment it's 1. So what I want you to note is as these things change, as I move this around, the slope is always going to be the same as whatever that is on that slider called M, because that's changing the leading coefficient here. In a linear polynomial, the slope is the leading coefficient. If I change to C, that's moving it up and down. So when a C is, say, -4, the y-intercept is -4. In a linear polynomial, the y-intercept is always the same as the constant. Okay, so one thing you could do, maybe I might just change the increments back and do a little bit of artistry here, 0.01. That's just how much it's going up by. And I'm also going to look at C here. And I change the increment to 0.01. And again, I really encourage you to practice this stuff. And I'm going to just animate both of those things. You can see as the slope changes here, as M changes, that's the leading coefficient in the polynomial. That's changing the slope. This is the constant in the polynomial. As that's changing the y-intercept. And again, you know, if you want, you can just stick a trace on that and get a nice kind of pattern emerging there. Okay, just a little bit of artwork there. And GeoGebra, a little bit of GeoGebra practice. But ultimately, the big thing to remember from this class is that this is one way to write the equation of a line. M is always the slope, C is always the y-intercept.